Hello everyone, we are the student of Chanakya University. I am welcoming you all to in our research paper video where I am going to explain you about heart disease prediction using machine learning. It's a comparatively study with some real world example. I'm going to take you through how machine learning helps in diagnosis heart disease early and efficiently. In the abstract of our research paper, heart disease is a global health crisis as we all know. It's one of the top causes of death worldwide. The sooner we can detect it, the better the outcome for the patient. In our study, we applied various machine learning models such as logistic regression, decision tree, random forest, and support vector machine, and k-nearest neighbors. We used a real-world data set with 14 clinical features like blood pressure and cholesterol, etc. After pre-processing and selecting the most important feature, random forest stood out. It gives us 91% accuracy, 89% precision, and a 19% F1 score. This shows how crucial good data preparation and the right model are medical diagnostics. Again, as we all know, every year nearly 18 million people die from cardiovascular disease. Traditional methods for diagnosing heart disease are often invasive and costly. Machine learning offers a smarter solution. It analyzes patient data and identifies hidden patterns that could signal heart disease. However, many models face issues like overfitting and poor interpretability. That's why we tested the multiple model and focused on improving them through better feature selection. Our goal was to build a reliable and practical system to help doctors detect heart disease early and supporting clinical decision in a fast and cost-efficient way. And here the our dataset description where we use the UCI heart disease dataset. It includes 1025 patients record and 14 key attributes such as age, chest pain type, cholesterol, and resting blood pressures. The target variable simply indicates whether the person had heart disease or not. Huh. Let's take a real world example. Like this is a similar to what hospitals like Cleveland Clinic use non-invasive methods to assess heart disease risk by evaluating patient's history and lab results. Again, here are data pre-processing. Before training our models, we clean the data. First, we check for missing values. Fortunately, there were none. We encoded any categorical data, so model could understood them. Then we scale the feature using the standard scaler, which ensure all data points are to be same scale. And here we are taking one real world example. In clinical practice, this is like standardizing test results across patients to ensure consistency. For instance, cholesterol levels are interpreted in the same way for everyone. Again, we having feature selection. Next, we perform the feature selection in our research paper to find out which attributes are most important. We use a technique called select k-best with mutual information scoring. We selected feature like chest pain type, maximum heart rate, exercise included, angina, and cholesterol. Here we are going to take one real-world example which focus on symptoms like chest pain when doctors focus on those systems, cholesterol levels, so our model mimicking how clinicals think when assessing a patient. Again, here are model implementation. As you can see, there were original model implementation included ANN, decision tree, and AdaBoost and SVM. And we implemented models such as logistic regression, random forest, and KAN. We implement total 6 machine learning models. As I already told, logistic regression, random forest, KAN, and support vector machine, AdaBoost with decision tree. These models are commonly used to help data analysis. We replace earlier models like artificial neural network with these simpler, most interpretable methods that are easier to implement in real hospital systems. Now I am going to explain you the result of original models implementation. Original models were four. First, ANN, second, decision tree, AdaBoost, and SVM. ANN inspired by the human brain to detect patterns. Accuracy of ANN is 98.08%, whereas F1 score is 97.09%, and ROC-AUC of ANN is 69.03%. Again, decision tree. Decision tree split the data into branches based on the feature threshold. While highly interpretable, they are prone to overfitting if not pruned. Accuracy of decision tree is 84.0%, where the F1 score of decision tree is 82%, and the ROC-AUC is 89%. Now we're coming to AdaBoost. AdaBoost is a boosting ensemble that focus on misclassified samples, improving prediction iteratively. Accuracy of AdaBoost is 87%. F1 score of AdaBoost is 85%. ROC-AUC of AdaBoost is 92%, as I mentioned. And now we are coming to SVM. SVM stands for support vector machine. It's aiming to find the optimal margin between two classes using support vectors. They perform well in high dimensional data, but are sensitive to scaling and kernel checks. Accuracy of SVM is 86%, whereas F1 score of SVM is 84%, and ROC-AUC is 91%. And here we have the bar graph analysis of those models. That orange color is for ANN, and the blue bar is for decision tree, and the green bar is for AdaBoost, and red is stand for the SVM, where it's showing the sensitivity, specificity, and accuracy and the AUC of all four models. Wait, you do. Now I'm going to explain you our own implemented model, where we will do model analysis with some real world comparison. First, we having logistic regression. This model is a widely used in medicine for binary classification. It achieved 85% accuracy and F1 score of 83%. Just think in real world example. Many hospitals use logistic regression model in clinical decision support system to predict patient risk based on the vital signs. Again, now we having random forest model. This ensemble model of decision trees gave us the best performance, 88% accuracy and 93% ROC-AUC. And we can think some real world example like platforms like IBM. Boston Health use similar models to estimate disease risks and assist with early diagnosis. And the third one is we having K nearest neighbors. KNN is a simple yet effective method. Looks at similar patient cases. It's an on accuracy of 83%. Here also we are taking one real world example. Like health wearables like smartwatches use KNN like approaches to flag abnormal heart rates by comparing your data with similar users. Next, we will do model evaluation of our implementation. We evaluated each model using metrics like accuracy, F1 score, ROC, AUC, and the confusion metrics. Random forest had the best balance, high accuracy, and very few false positive or negatives. This is important in the healthcare. A false positive can cause unnecessary panic, and a false negative can be life-threatening. Here I'm going to show, like we are seeing this. There is a logistic regression model which got accuracy 81%, F1 score for 82%, and ROC-AUC is 86%. And random forest, as we can see, it's got the highest accuracy for 99%, and F1 score for random forest is 98%, and ROC-AUC for 99%. And another side, KNN got accuracy for 82% and F1 score for 82%, and also ROC AUC for 95%, where we can compare. Random forest give efficient and best result. Now we are going to now I'm going to explain you some real now I'm going to explain you some real world application and future scope. Like AI powered diagnostic system are already being used in many of hospitals. Like the Mayo Clinic use the AI to flag patient at risk of heart disease early, even before symptoms appear. Our ML pipeline aims to offer the similar benefits as Mayo Clinic uses. Accurate the prediction and transparent reasoning behind them. In the future, we plan to include lifestyle factors like diet, exercise, and medical history.
Hello. Now I'm going to explain the .py code of implementing the models. First, importing libraries. This slide shows the Python libraries needed to build the machine learning models such as Pandas, NumPy for data manipulations, Matplotlib and Seaborn for data visualization, and sklearns for machine learning tasks, model building and evaluation. Next, we are loading the dataset. In the loading the dataset, the this column explains how the dataset likely and hard.csv is loading using pandas.read.csv, and it is stored in a data frame for an analysis. In this slide, we are displaying the first 5 lines of a dataset. df.head, which is used to display the first 5 rows of a dataset. This helps to understand the structures and values of data. Next, to display the total dataset and the columns. This slides includes df.info and df.shape, which shows the number of columns, column names, and the total number of data types and non-numerical counts. Next, here we are checking for the missing data usage. df.null.sum handling missing values is crucial before training a machine learning model. Next, here we are explaining about the data visualization. It initializes the visualization of data using some of the plots like correlation, heat map, it counts the plots for target variable and distribute the features among the heart disease features. Next, here is the another data visualization called pair plot, which selects the 7 columns and the target, which this uses the Seaborn report shows pre-wise relation in the dataset to help identical patterns and correlation between the features. And next, here we explain about the histogram. Histogram of features shows the frequency of distribution of data, helping identify the sickness, outliers, or the transformation needed. Next, we move on to the feature scaling and selection. Feature scaling, for example, standard scalar or min max scalar, is applied to normalize the data. This feature is basically to normalize the data. Feature selection might use correlation or model based importance to choose a relevant features. And here we are train and test split. Here we are splitting the data is splitting into training data set using train test split to evaluate the model performance on an unseen data. Here the test is 30% and the train is 70%. Next, we are defining the models. Different machine learning models are defined. Those includes SVM, decision tree, random forest, XGBoost, logistic regression, and k-nearest neighbors. SVM, decision tree, and the XGBoost. These three are the models which are in original research paper. The model which are implemented by us are decision tree, logistic regression, and k-nearest neighbors. Later, now we are going to train and evaluate models. In this train and evaluate models are trained using the model.fit And predictions are evaluated using the matrix like accuracy, F1 score, ROC and AOC, and classification report. Now, let us see the output and the comparison between the models. First, the model is SVM. It has accuracy of 0.86 and the F1 score as 0.86 and ROC and AOC as 0.94. And second model is decision tree. It has accuracy of 0.97, F1 score as 0.96 and ROC USC as 0.96. Next, we have random forest. Here, the accuracy is 0.98, F1 score is 0.97 and ROC AUC is 0.99. Next, we have a model AdBoost. AdBoost accuracy is 0.82, F1 score is 0.82 and ROC is 0.92. Next, we have a model called Logistic Regression. It has accuracy of 0.81, F1 score as 0.82, ROC OC as 0.86. Next, the k nearest neighbors. Here it has accuracy of 0.82, F1 score as 0.82, and ROC and AUC as an 0.95. By comparing all these model, we get the highest accuracy of 98% in the model called as random forest. Next, we move on to the model matrix. These detailed explanation of tabular of an evaluation of matrix. In this, using these are the accuracy, precaution, F1 score, and rescore. Using these values, we created a model matrix to construct a confusion matrix plots. Let us move on to the confusion matrix plots. This is the code to plot and confusion matrix. These are the outputs. After using the models, we have created the confusion matrix. Let me explain what is confusion matrix. Confusion matrix, it involves four types. One is true positive, false positive, true negative, and false negative. Let me explain through each diagram of each model out. First, we have SVM. It has 135 true positive and 130 true negative. Next, we have decision tree. It has 159 true negative and 0 false positive. Next, we have random forest. It has 143 true positive and 6 false negative. And the confusion matrix. Next, confusion matrix of an AdBoost. It has 22 false negative and 32 false positive. Next, we have logistic regression. It has 135 true positive and 115 true negative. Next, last confusion matrix, k nearest neighbor. This confusion matrix has 130 true negative and 124 true positive. Next, we'll come to ROC curve. This ROC curve receives operating characters curve visualizing model performance. What basically the ROC curve shows is true positive versus the false positive rate. AUC is the area under curve to compare the model effectiveness.